So now let's talk about dividing a polynomial by a binomial. This is when that iterative process of long division that I covered in the review section a couple videos ago is really going to be beneficial. So let's go through the steps. We're going to work through a lot of examples. I'm going to try and go very slowly. So here are the steps. So first thing, you want to arrange the terms of both the dividend and the divisor, so what you're dividing and what you're dividing by, in descending powers of the variable, right? We always want the largest variable first, second, third, and our constant last, right? Next, then we're going to divide the first term in the dividend by the first term in the divisor. And the result is going to be the first term of our quotient. We multiply every term in the divisor by the first term in the quotient, and we write the resulting product beneath the dividend with the like terms lined up. We subtract the product, right? That sounds familiar, right? We multiplied and then we subtract in that iterative process. Next, you bring down the next term, just like before in long division, we'd bring down the next digit. You bring down the next term and write that next to the remainder to form a new dividend. Now you're going to use this new expression and the new dividend and repeat this process. So you go back up, right, and repeat the process until the remainder can no longer be divided. This will occur when the degree of the remainder, which is going to be a polynomial, is less than the degree of the divisor. So why don't we go ahead and I'm going to show you a picture of an example and I'll walk us through it step by step. So here's an example of polynomial long division, right? Here's our dividend, here's our divisor. So let's go ahead and walk through this. So I've got 3x to the fourth plus 12x cubed plus 7x squared plus 0x minus 1. Now, why do I have a 0x? Well, I'm going to talk about that we always need a placeholder, and you'll see why. Divided by x plus 3. So I'm going to take this first term, and I'm going to say, okay, what do I multiply x by to make it look like 3x to the fourth? Well, I know I'm going to need to multiply it by a 3. 3 times x would give me 3x, but it needs to be 3x to the fourth, so that's actually going to be 3x cubed. So I take 3x cubed times x, that gives me 3x to the fourth, but I have this other term here, right? So then I have 3x cubed times 3, which gives me a 9x cubed. Then I'm going to subtract. My first term should always cancel. If I didn't, I made a mistake, and I can fix that. But I've got 12x cubed minus, because we distribute that negative, 9x cubed, which leaves me with 3x cubed, and then I pull down this next term. Okay, this is my new term, and I say, okay, what could I multiply x by to make it look like 3x cubed? How about 3x squared? 3x squared times x gives me 3x cubed. 3x squared times 3 gives me 9x squared. And then I subtract this. My first terms cancel. 7x squared minus 9x squared would be a negative 2x squared. And then I pull down my next term, which is a placeholder. One thing that's true is that when we're dividing polynomials, every possible power of our variable below our highest variable degree needs to be represented, and I'll show you why in a second. So what would I multiply x by to make it look like negative 2x squared? How about a negative 2x? Negative 2x times x gives me negative 2x squared. Negative 2x times 3 gives me a negative 6x. Notice how if I didn't have this placeholder here, I wouldn't have anything to subtract from. My first terms cancel. Two negatives make a positive, so I have 6x minus 1. Of course, I'm running out of room. If I take, what do I multiply x by to make it look like 6x? Well, that's a 6. 6 times x is 6x. Change color so you can see. 6x. 6 times 3 is 18. We go ahead and subtract. My first terms cancel. Negative 1 minus 18 gives us a remainder of negative 19. So this is that iterative process like long division that we've seen before. So let's work through a bunch more examples so we have lots and lots for reference. So I have x squared minus 17x plus 74 divided by x minus 5. I'm going to rewrite this so we're all set up for our long division. So I look at my first term, my divisor, and I say, okay, what do I multiply x by to make it look like x squared? Well, that's just going to be x. Then I multiply. X times x is x squared. X times negative 5 is a negative 5x. We subtract. My first terms cancel. This becomes a positive. Negative 17x plus 5x is a negative 12x. And I pull down my next term. Okay, what do I multiply x by to make it look like negative 12x? That's going to be negative 12. Negative 12 times x is negative 12x. Negative 12 times negative 5 is a positive 60. I go ahead and subtract. My first terms cancel. 74 minus 60 is 14. So here's my remainder. Here's my quotient. I could rewrite this if I wanted as x minus 12 plus my remainder over my divisor. So plus 14 over x minus 5. Let's work through another example. So I have 2x squared plus x minus 10 divided by x minus 2. Now be careful. The denominator is not a monomial. So you're going to want to rewrite this. I've got x minus 2, and we're dividing 2x squared plus x minus 10 by it. So I look at x and I say, okay, what do I multiply x by to make it look like 2x squared? Well, that's going to be a 2x. 2x times x is 2x squared. 2x times negative 2 is a negative 4x. I go ahead and subtract. My first terms cancel. Two negatives make a positive. X plus 4x is 5x. And I pull down my next term. Okay, what do I multiply x by to make it look like 5x? Well, that's going to be 5. 5 times x is 5x. 5 times negative 2 is negative 10. When I subtract these, everything's going to cancel. Oh, so that means it divides evenly. How can I check my answer? Well, what if I took x minus 2, which was our divisor, times our quotient? Now we know how to FOIL. We can do this. X times 2x is 2x squared. X times 5 is a positive 5x. Negative 2x times negative 2 times positive 2x is a negative 4x. And negative 2 times 5 is 10. Oops, and negative 10. Combine like terms to get 2x squared plus x minus 10. They're even divisors, so they're multiples of each other. For example, if I took 10 divided by 2, you agree that I'd get 5, right? And 2 times 5 is 10. All right, we have 3 more examples to work through. If I have 3x squared minus 2x plus 5, and I'm dividing that by x minus 3, we're going to follow the same process. I say, okay, what do I multiply x by to make it look like 3x squared? Well, that's going to be 3x. 3x times x is 3x squared. 3x times a negative 3 is a negative 9x. And we subtract. My first term's going to cancel. If it doesn't, I made a mistake. And you can erase your work, go back and fix it. Negative 2x minus a negative 9, that becomes a positive. So I have 7x plus 5. What do I multiply x by to make it look like 7x? Well, that's going to be a 7. 7 times x is 7x. 7 times negative 3 is negative 21. Subtract that. I get 25 plus 21, so my remainder is 26. Let me mention that this is when I know how to stop, because my remainder is of lesser degree than my divisor. Remember, a constant has degree 0, our divisor has degree 1, so I know I'm done. So 26 is my remainder. I have 3x plus 7, plus if I wanted to include the remainder, 26 over x minus 3. That's what's left over. Next, I have 7x minus 9 minus 4x squared plus 4x cubed divided by 2x squared, 2x minus 1. So kind of when you see this numerator, your gut instinct can kind of be to go, ew, like, ew, there's something wrong with this polynomial in the numerator. And what is it? Well, it's not written from largest to smallest degree. Things that should give you kind of an ew gut feeling, and you know you need to fix it. So I've got 4x cubed minus 4x squared plus 7x minus 9. See, now all is right with the world. Less ew. Let's go ahead and divide. What do I multiply 2x by to make it look like 4x cubed? That's 2x squared. 2x squared times 2x is 4x cubed. 2x squared times a negative 1 is a negative 2x squared. We subtract. This becomes a positive. So I have negative 2x squared, pull down my next term, plus 7x. So what do I multiply 2x by to make it look like a negative 2x squared? Well, that's going to be negative x. So I have negative x times 2x is negative 2x squared. Negative x times a negative 1 becomes a positive x. We subtract. And first terms cancel. 7x minus x is 6x. We pull down our next term. What do I multiply 2x by to make it look like 6x? That's going to be 3. 3 times 2x is 6x. 3 times a negative 1 is a negative 3. We go ahead and subtract. My remainder is 6. So I've got 2x squared minus x plus 3 plus 6 out of whatever my divisor was, which is 2x minus 1. Or you can write it as 2x squared minus x plus 3 remainder, just a letter r, 6. And that tells us what our remainder is. So for this last example, example 5, I've got 8x cubed minus 1 divided by 2x minus 1. Now notice I'm missing some terms here. This is where I'm going to have to use a placeholder. So I'm going to take 2x minus 1 and I'm going to divide 8x cubed minus 1, but I need to put in some placeholders. I'm going to have 0x squared and 0x. I need to make sure that every term between x cubed and our degree 0 constant is represented. So what do I multiply 2x by to make it look like 8x cubed? That's going to be 4x squared. 4x squared times 2x is 8x cubed. 4x squared times negative 1 is a negative 4x squared. We go ahead and subtract. I get 4x squared because two negatives make a positive and my first terms cancel. And then I pull down my next term. See, we had to have a placeholder, so we had something to add 4x squared to. Now I look at 2x and I say, okay, what do I multiply 2x by to make it look like 4x squared? That's going to be 2x. 2x times 2x is 4x squared. 2x times a negative 1 is a negative 2x. I'm going to go ahead and subtract. First terms cancel. Two negatives make a positive, so I've got 2x minus 1. Well, what do I multiply 2x minus 1 by to make it look like 2x minus 1? Well, that's 1. So my final answer is 4x squared plus 2x plus 1, and my remainder is 0.